Hello, students. Welcome to Engineering Geology and Hydrology. Today we are going to learn about geological hazards of earthquakes. May 21st, 1960, 3 p.m. A magnitude 9.5 earthquake struck Chile. It was the largest earthquake ever recorded. It has killed 20,000 people in Chile. The destruction of the earthquake was shocking. We have to learn more about earthquakes. In the future transportation construction, minimize the damage from earthquakes as much as possible to our roads and railways. First, let's look at the concept of an earthquake. An earthquake refers to the shaking of the Earth's crust. An earthquake that occurs under the sea is called a sea earthquake. Earthquake is a geological phenomenon. It is a manifestation of crustal tectonic movement. China is an earthquake-prone country, located between the world's two major seismic zones. Under the compression of the Pacific Plate, the Indian Plate and the Philippine Plate, seismic fault zones in China are well developed. China has a high frequency of seismic activity, great intensity, shallow focus, widespread. It is a country with severe earthquake damage. Since 1900, as many as 550,000 people died in the earthquake in China. It accounts for 53% of the world's earthquake deaths. Memories of the earthquake are undoubtedly painful. In our country's history, let's learn about 3 devastating earthquakes. Guangzhou earthquake is one of the most severe disasters recorded in Chinese history. The death toll is rare anywhere in the world. According to Ming history, it killed more than 830,000 people. It was 1.3% of the population at the time. The Tangshan earthquake, with a magnitude of 7.8, killed an estimated 240,000 people and seriously injured 160,000. The Wenchuan earthquake had a magnitude of 8.0. About 70,000 people were killed. About 370,000 people were injured to varying degrees. Classification of earthquakes. According to the cause of formation, the classification of earthquakes can be divided into volcanic earthquake, collapse earthquake, and induced earthquake. Tectonic earthquake refers to crustal movement causes sudden changes in crustal structure. The layers of the Earth's crust are broken, causing the Earth's crust to shake. This is what we call an earthquake most of the time. More than 90% of the world's earthquakes are tectonic earthquakes. The destructive power of strong tectonic earthquakes is very great. It is the primary earthquake type for human earthquake disaster prevention. The second type, volcanic earthquakes, which caused by magma erupting during volcanic activity, or an earthquake caused by heat. Such earthquakes are generally small in magnitude, also causes less damage. It accounts for only about 7% of all earthquakes. The third type of earthquake is a collapse earthquake, because the groundwater dissolved the soluble rock, causing holes in the rock, and it's gradually expanding, or because of underground mining of ore, forming a huge void, resulting in the collapse of the rock tops and soil layers. Induced earthquake. We call it a collapse earthquake. Such earthquakes account for about 3% of all earthquakes. The magnitudes are relatively small. Induced earthquakes are generally earthquakes caused by human activities, such as the construction of reservoirs, nuclear tests and explosions, and so on. The classification of earthquakes can also be followed. Depth of the source is divided into deep sources, moderate and shallow earthquakes. A deep source earthquake is one with a depth greater than 300 kilometers. Medium source earthquake refers to the focal depth between 70 and 300 kilometers. A shallow earthquake is one with a depth of less than 70 kilometers. Earthquake-related terms. A focal point is a place underground where an earthquake occurs. The epicenter refers to the ground directly opposite the epicenter. Epicenter distance refers to the distance from any point to the epicenter. In the diagram on the right, This location is the source. This location is the epicenter. This location is the epicenter distance. Earthquake wave. The energy released by the source of an earthquake travels around in the form of elastic waves. Phenomenon of tremor produced. We call them seismic waves. Seismic waves can be divided into body waves and surface waves. Body waves are seismic waves that travel within the earth. Surface waves are body waves when they reach the surface, under certain conditions, resulting secondary wave. The magnitude of the earthquake. Indicate an earthquake. The scale of its own energy release. An earthquake has only one magnitude. Earthquakes are divided into 4 categories according to their magnitude. A magnitude less than 3 is called a weak earthquake. Greater than 3 and less than or equal to 4.5. We call it a felt earthquake. Greater than 4.5 and less than 6. We call it a moderate earthquake. Greater than or equal to level 6. We call it a big quake. Weak earthquakes are generally not noticeable. A felt earthquake usually causes no damage. Moderate to strong earthquakes can cause damage. Strong and giant earthquakes can cause serious damage. Earthquake intensity refers to the ground in an area and various buildings. The extent of the earthquake damage. An earthquake has only one magnitude. The intensity can vary by region. China divides the earthquake intensity into 12 degrees. Earthquake damage to engineering construction. Through this picture, we can learn. Earthquakes can cause bridges to collapse. These 2 pictures we can see. During the earthquake, the bridge broke and collapsed. Earthquakes can damage tunnels. The stability of tunnel entrance during earthquake. A sabotage was carried out. Earthquake time. It could also cause the tunnel to collapse. Earthquake damage to roadbed engineering. It is mainly manifested in the fault of the roadbed and the slope instability along the soil. Earthquake protection of highway and railway engineering. Highway and railway line selection. Avoid active faults whenever possible. The design should strictly adhere to the seismic fortification requirements of the area. Site selection should be carefully. Proceed geological hazard assessment and risk assessment. Avoid major geological hazards. Engineering geological conditions of construction site shall comply with the principle of avoiding and reducing earthquake hazards as far as possible. Safety problems in highly geological hazard vulnerable areas. Timely remedial measures should be taken. The government and the broad masses of the people have taken an active part in preventing and quashing earthquakes. In this lesson, we focused on the concept of earthquakes. An earthquake is a shaking of the Earth's crust. Earthquakes can be classified according to their formation conditions. It can also be classified according to the depth of the source. Related terms for earthquakes include source, epicenter, epicentral, distance, seismic wave, surface wave, body wave, earthquake magnitude, and the intensity of the earthquake. Earthquake damage to engineering construction is very great. It can cause bridges to break and collapse. Tunnel collapse, opening, instability, roadbed cracking, deformation, transformation, and slope instability. For earthquake protection, we can do this by circumventing earthquake fortification, geological disaster assessment, risk assessment, avoid and reduce geological disasters, timely remediation of vulnerable areas, full participation in earthquake prevention, etc. 6 major measures to reduce the impact of geological disasters on our engineering construction.